Hello viewers, in today's class we are going to discuss an important problem from limits, right? So here we are going to solve one very important conceptual problem from calculation of limits, and here we'll see whether the limit x tends to 1 2 times greatest integer of 2 plus x exists or not, right? So here we'll find out the right hand limit and the left hand limit of this function where the greatest integer function is involved, right? So let us start. So first of all, what we will do, we'll take f of x is equal to 2 times greatest integer of 2 plus x, right? So we have to find the limit x tends to 1 2 times greatest integer of 2 plus x, or in other words we can say that we have to check whether the limit exists or not, right? So we'll write limit x tends to 1 f of x, right? So what we will do, in order to exist the limit, what we have to do, we have to separately find the right hand limit and the left hand limit, right? So when the right hand limit exists and it is finite, exist and finite, and similarly if the left hand limit it also exists and finite, and moreover both these limits are equal, then we can conclude that the limit of a function at the particular point exists, right? For example, suppose we have a function, say f of x, right? And let us take a point x is equal to a in its domain, right? So suppose we have to see whether this limit x tends to a f of x exist or not. So what we will do, we'll find the right hand limit, that is the limit x tends to a plus f of x, and then we find the left hand limit, that is limit x tends to a minus f of x, right? And if both these limits exist and finite and are equal, then we can say that the limit of this function at x is equal to a exists, right? So here also we'll find the right hand limit and the left hand limit. So here let us find the right hand limit. So the right hand limit, it can be given by limit x tends to 1 plus this positive sign shows that we are calculating the right hand limit. Here we have f of x, right? So now here we have limit x tends to 1 plus, for f of x we can write 2 times greatest integer of 2 plus x, right? Okay, so now here what we will do, we'll take x is equal to 1 plus h, right? So we'll make this substitution here, and here h is a positive quantity and it is greater than 0, right? And moreover h lies between 0 and 1, right? Okay, so when x tends to 1, then obviously h tends to 0, right? So from this relation we can write the right hand limit as limit, here x tends to 1 plus now becomes limit h tends to 0, and here we have 2 times 2 plus x, for x we can write 1 plus h, right? So this is limit h tends to 0, we have 2 times greatest integer of 3 plus h. Okay, so now here we see that we have the greatest integer of 3 plus h, right? So as we have just said that h is a quantity, positive quantity, which is greater than 0, and moreover h lies between 0 and 1, right? So h has some positive value, right? And h is a very small quantity, so 3 plus h is slightly, it is greater than 3, but it is less than 4, right? So by definition of greatest integer function, the value of greatest integer of 3 plus h is equal to 3, right? So now here we can write 3, so we have limit h tends to 0 and 2 times 3, right? So since we do not have here any term containing h, so we can omit this limit h tends to 0 sign or symbol. So we have 2 3s are 6, right? So the right hand limit of this function when x tends to 1 is 6. So we can write it here. So right hand limit is equal to 6. Okay, so now let us find out the left hand limit. So now the left hand limit is given by limit. Here we have x tends to 1 minus f of x, right? So the negative sign shows that we are calculating the left hand limit. So here we have limit x tends to 1 minus, and for f of x we can write 2 times greatest integer of 2 plus x, right? So now again we'll make the substitution, and in this case while calculating the left hand limit we can take x is equal to 1 minus h, right? See, here we have the point x is equal to 1, right? So when we are approaching towards x is equal to 1 from the left hand side, all the values are less than 1, right? So all the values which lies towards the left of x is equal to 1 are less than 1, and when we approach towards x is equal to 1 from the right of x is equal to 1, all the values which are lying towards the right of x is equal to 1 are greater than 1, right? So here we'll consider 1 minus h, and here we'll take 1 plus h, right? So now here x is equal to 1 minus h. So when x tends to 1, obviously h tends to 0, and moreover h is greater than 0, that is h is greater than 0 but less than 1, right? So h lies between 0 and 1, and h is a very small quantity, right? Okay, so now here the left hand limit can now be written as limit. For x tends to 1 minus, we can write h tends to 0, and here we have 2 times and 2 plus. For x we can write 1 minus h, so we have limit h tends to 0 2 times, this is 3 minus h, right? So again we have a term that is greatest integer of 3 minus h. So now here we have the term that is greatest integer of 3 minus h, and since h is greater than 0, so 3 minus h is slightly less than 3, but it is greater than 2, right? So 3 minus h is greater than 2, but it is less than 3. So obviously the greatest integer of 3 minus h is equal to 2, right? So now we have limit h tends to 0, and we have 2 times 2, right? So for this term we can write 2. Okay, so now see here we do not have any term containing h, so we can remove this symbol, that is limit h tends to 0. So we are simply left with 4, right? So 2 2s are 4. So the left hand limit of this function when x tends to 1 is 4, right? So here we see that the limit of this function when x tends to 1, the right hand limit is 6 and the left hand limit is 4. Although the right hand limit is finite and it exists, similarly the left hand limit is also finite and it exists, but right hand limit is not equal to the left hand limit, right? So 6 is not equal to 4. So we conclude that by this definition that the limit of this function when x tends to 1, it does not exist, right? So this limit L does not exist because the right hand limit and the left hand limit, although they exist and finite, but they are not equal.